Covalent bonding time. Alright. Okay, so today we're going to talk about covalent. I'm already misspelling the first word, covalent bonds. We talked earlier about ions, isotopes, and such. We talked about bonding, where they're going to hold hands. We did briefly talk about this during Lewis structure. I just didn't tell you what it was, so you've been doing it already. You just didn't notice it. So covalent bonds is when we have two or more non-metals holding hands or sharing electrons. Ionic bonds is where they take or give one. Covalent bonds, they're actually going to share. So the big part about this is sharing. Sharing, caring. And they're going to share electrons. Let's actually make it really sharing electrons. Alright. So let's get a periodic table. And the best way to learn this one is actually practicing with it, in my opinion. Instead of taking notes, we're just going to look at this and practice. So you might need to grab some paper or dry erase marker on the tables and just work on practicing with them. Let's pick two nonmetals. Actually, let's start with something easy. Hydrogen. Let's say we have two hydrogens. Oop. And we have hydrogen by itself. Let's actually make that a little bolder there. Another hydrogen. Now remember, they have one valence electron each, and there's the Lewis structures. You know, I'm thinking right now, man, we've already did part of this. I know, but now we're adding the bonding piece on what it actually means. So we have this hydrogen, and had another hydrogen, and they want to be happy. Right now, they're not happy. They do not have a full octet. We want them to have a full octet. But since hydrogen's on the first period, they get have only two electrons. So these guys are like, hey, cool, dude, you're cool and all. Let's hold hands. They're gonna hold hands. In the process of doing this, each part of the hand is actually an electron. So this hydrogen has two electrons now. This one over here has 1 and 2. They're sharing. So now this one is happy, and this one is happy. Remember, this kind of builds on when we did the Lewis dot structure earlier last week. Okay, let's mix it up now. Let's go back to something we've done before, but just go practice with H2O. Let's put the Lewis structure for those. Hydrogen has 1, so we have 2 hydrogens and 1 oxygen. Oxygen in the periodic table is 6A, so 1, 2, 3, 4, 5, 6. Okay. So what this guy wants to do, since he does not happy, he does not have 8, he's not happy, he's not full, he's not happy, he's not full. They're going to say, hey, let's all hang out, let's hold hands, let's share our electrons to form bonds to be full. So this hydrogen's going to go, hey, dude, what's up? Let's share our electrons, man. And they're going to hold hands, forming a single bond. Now this hydrogen right here is happy, but oxygen is still not. He only has 1, 2, 3, 4, 5, 6, 7. He needs that 8th one. They say, hey, hydrogen, come on over. Let's share that electron. Let's hold hands. So now oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. He is now happy. This guy is happy. This guy is happy. All right. So yes, we've already done this earlier last week, but now you know, since we have two nonmetals, we're bonded together covalently. All right. Easy peasy, right? So let's go over some quick vocabulary. We have electrons when they're by themselves, not involved in a bond. They're always going to try to pair up. They never want to be by themselves like this. They want to be paired up. We call these lone pairs. They're by themselves and they're in pairs. If we have holding of hands, we call these bonds. That means their electrons are being shared across. If we have just one bar, we call this a single bond. If we have two bars, call this a double bond. If we have three bars, we call this a triple bond. Easy peasy, right? All right, let's take this. Let's do a few more, at least 2 or 3. Let's work with NH3, and again, we've done this exact formula last week. Just need special practice with it. Nitrogen, we have. I forgot how many electrons are nitrogen. 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 3 hydrogens. 1, 2, 3. Wait, did I put 7 on nitrogen? That's not right. 5. Oh my gosh, I can't believe I didn't read the periodic table right. See? Yeah, I put 7 protons. 7 electrons total, of 5 in the outside ring. Silly me. Okay. So right now, he's not happy. He's not happy. None of these guys are happy. They want to have a full outside ring. So nitrogen is going to go over here. Say, hey, nitrogen, hydrogen, let's bond. Good. I'm going to take this hydrogen over here. Come over this way. He's going to move this guy over here. And he's going to, let's hold hands. We're going to bond. All right. I'm going to take this one. He's going to move over this way. He's going to hold hands. We're going to bond. And now we have a full set. So hydrogen here has 1, 2. That one also has 1, 2. 1, 2. They're happy. Because in the first period, you can have a max of 2. Nitrogen, though, he needs 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. All right. Remember, if you need to, pause this video. Take a second to reflect and everything. If you need to, don't. If it's going too fast, beautiful thing about videos, hit pause. All right, let's do another one. So, let's do a diatomic. Diatomic means 2, or in pairs, of N2. Okay. So nitrogen again should have a total of, let's see here, 5 valence electrons. So nitrogen, 1, 2, 3, 4, 5. Another nitrogen, 1, 2, 3, 4, 5. These two want to bond together. So we have 2 nonmetals. So we have covalent. All right, so let's put them close together. So right away I can say, well, these two want to bond. But that's really small. They want to bond. Okay. Are we done? Nope. We can't have these guys just sitting on by themselves. Right now this one has 1, 2, 3, 4, 5, 6. He's still not happy. And we can't have these guys by themselves. So what we're going to say is, well, we can share another set of electrons. Let's bring them on over. Let's share. All right, so now we have 1, 2, 3, 4, 5, 6, 7. So this nitrogen is still unhappy. This one also has 7, so he's still unhappy. So we're going to say, hey, well, I still have these electrons by themselves. Well, we can go ahead and move them on over and share another set. We're going to have 3 hands holding each other. Well, that's kind of weird. We only have two. Electrons can have more than two. So now, let's count our electrons. 1, 2, 3, 4, 5, 6, 7, 8. Oh, this nitrogen is happy. This one, 1, 2, 3, 4, 5, 6, 7, 8. He's also happy. They're now fully bonded. Now, since we have 3 lines, 3 bonds, this is a triple bond. So this covalent bond is tripled. Oh, okay. What's going on here? A weird email. Okay. Let's try one last one just for practice. Let's stay again with the diatomics, or the ones just pairs, because it's easier right now. I want to practice a little bit more another day with more complex ones. We have O2. Two O's. In the periodic table, see how many valence electrons they have? 6. So 1, oh no, what happened there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These two need to be bonded together in a covalent bond. Well, just bring them a little bit closer together. Well, these two electrons can hold hands. Single bond. Let's see. Now we have 1, 2, 3, 4, 5, 6, 7. Not enough. So let's have more sharing. Let's bring this electron over here. You really pick any of them. And then we're going to hold hands. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, he's happy. Look at that, he's happy. What about this one? 1, 2, 3, 4, 5, 6, 7, 8. He's also happy. So we're done, right? Almost. To see these electrons by themselves, they cannot be just hanging around by themselves. They need to be paired up. Let's move those over here, and now we have lone pairs. Lone pair, lone pair, lone pair, lone pair, and a double bond. We are good. That's it. All right, so use this as the help video. I have some practice for you to do in Canvas. Let's watch a cool intro video. Yay. Bye.